Hello everyone. As part of our internship, we had the opportunity to work on this development project in pairs with Hugo Heilmann and Dorian Guigon under the supervision of Van Lichtran, our internship mentor. The main goal was to design an application capable of visualizing in real time the position of different connected devices while providing a clear and intuitive interface for their management. To achieve this, we developed the application using HTML, CSS, and native JavaScript in order to ensure a lightweight, smooth, and fully customized solution. In this project, the API was provided to us from the start. Our mission was therefore to develop the entire graphical interface. Upon entering the application, the user is greeted with a login page. They have two options: either login with their email address and passwords, or register with an email, a password, and a phone number. For the phone, the user must select a country code, and depending on that choice, the placeholder format automatically adapts to the country's conventions. For example, if I select Vietnam's country code, the phone number field is displayed with the format 3 times 3 digits. Once logged in, the user accesses the core of the site, a leaflet map centered on Da Nang in Vietnam. On this map, 2 types of markers appear: antenna-shaped pins, representing the different gateways retrieved from the API, and classic pins similar to those in Google Maps, representing the devices detected by this gateway. When clicking on a gateway, a small pop-up appears showing its identifier and an additional value that will be implemented soon. This pop-up can be closed either by clicking the cross or directly on the map. Similarly, when clicking on a device, a pop-up appears with its identifier, name, as well as the date and time of detection. If a device has a position history stored in the database, up to 5 days of past movements can be displayed. Previous locations then appear as connected dots, making it easy to understand the paths taken through the city. Additionally, a panel at the bottom of the page summarizes the list of this position with their corresponding dates and time. Regarding device detection, there are 2 modes: by GPS coordinate, in which case the device is simply placed on the map, or by triangulation. In the second case, the device must be detected by at least 3 gateways. Each gateway provides its distance from the device, which is represented on the map by 3 circles, whose centers are the gateways. The intersection of the circles determines the precise position of the device. Finally, a control panel is accessible via a small arrow on the left side of the screen. This panel contains 2 tabs: Devices and Gateways. In the Devices tab, we find the list of all devices visible on the map, each with a checkbox to enable or disable its display. A Display All option allows checking or unchecking the entire list in one click. And to make the search easier, a text field allows filtering by name or identifier. The Gateways tab works in the same way, with its own list, global checkbox, and search field. It should be noted that hiding a gateway can affect the map. If a triangulated device is detected by only 2 gateways, it no longer has enough data and therefore disappears from the map. In conclusion, this project provides a simple and efficient solution for real-time tracking of connected devices while offering users an ergonomic and customizable interface. The clear display of data, flexible management of devices and gateways, as well as the visualization of movement history bring real added value for monitoring and analysis. This project also lays solid foundations for future developments, such as the addition of new data, the integration of advanced filters, or further optimization of triangulation accuracy.